In this video, I'm going to continue our discussion of XML. This is a presentation that I've adapted from Professor Robert Roque at the University of Cincinnati, Linder College of Business. So we talked about, in the last video, we talked about the history of XML, HTML, and SGML. In this video, we're going to focus on XML. So XML stands for Extensible Markup Language. So language good for data exchange. So it's a language that can be produced or read by a myriad of programming languages. C#, C++, Java, Perl, just about anything can create or read XML, which makes it ideal for interchange. XML is really a format, not necessarily a program. So you don't really program XML, although you can edit XML. So it's considered self-describing, which means that the content of the XML and the data of XML are together in the same document. So if you see Brandon, you know that Brandon is a first name, and you know that Jones is a last name, because Brandon would be enclosed within an element called first name, more than likely, and Jones would be in an element called last name, more than likely. So we're putting together the content and the data all in one unit. So XML is hierarchical, so it is made of a set of elements, and elements can have attributes as well. So an element, we talked about this a little bit earlier, we have open title and closed title. That would be one element. And then the text in between is SOA. So that would be what we would call child text, or the text within an element. So that's an element. Now an attribute is typically within the open tag of an element. So only the open tag, not the closed tag. Although if it's a singleton tag, that's okay. It can be in there as well. An attribute is typically a name and then an equals and then a value in quotes. So this is a way that we can take a look at XML. Now what do we mean by hierarchical? By hierarchical and by tree view, we mean that an XML file should properly follow a format of parent and child relationship. We can visualize this with something like this Code Beautify XML viewer. So I'm pasting in here an XML file that describes an Android application. Just an XML file I grabbed from an Android project that I have. Now, when I click on Tree View, take a look. It organizes this file into a tree view, so we can see the top level element is called module. And sure enough, if we take a look, we have an element called module that opens, and if I scroll down a bit, also closes this document. So that's what we're going to call a root element. Now within module is something called component. Within component you see facet, and then configuration, and then option. And for each of those that I mentioned, if you look closely, you can see that it highlights the close tag as soon as I click on the open tag. So you see it's a hierarchy: module, component, facet, configuration, option. Over here on the tree view, module, component, facet, configuration, option. So this is the text that we can see, and if you use XML a lot, you can really start to visualize this as a hierarchy. But if you're not used to XML, you can put it in something like this Code Beautify tool, and you can make a collapsible hierarchy that really describes the document well. Notice that it's a lot easier to read, as you can open and close these different, essentially, branches of the XML file. Okay, so good XML is going to have this hierarchical view. Okay, so XML document structure, a lot of times we'll start with an optional line that describes the document, just a little comment that says what XML version are we on. After that, many times we'll have a line that talks about how we are validating the document. And by validation, what we mean is, are the elements in the right position? Are we using only the elements that we're allowed to use? Do the elements have the values that they need to have? So on and so forth. So there are three ways to validate an XML document. There is DTD, document type definition, XSD, XML schema definition, and then well-formed, which means we trust the user to format the document appropriately. We'll talk about each of those in a separate lecture, but those are essentially describing the structure of the XML document and what a validated or a good XML document should look like. Okay. So XML elements, we talked a little bit about these different XML elements. We know that a well-formed or a good validatable XML document will have a root element. Now in our case, we can ignore this XML comment here. After that, notice that the first thing we see is an element called module. And at the end of the document, we see a close element called module as well. So that's what we'll call the root element. A good XML document will have that, in other words, an element that opens and closes the document, and that's called the root element because everything else is contained within this root element, in our case module. Now, the root element isn't always called module, that just happens to be the root element of this document that I'm looking at. But nonetheless, every good XML document should have that concept of a root element. Okay, so within that root element, we can take a look and we see that there are children elements. So right at one level down, there's the element called component. Then within that, there's an element called facet, within that configuration, and within that options. So you could say the great-grandparent, the grandparent, the parent, the child, and you can keep going on from there and kind of in a series of ancestry like so. So we'll see, we know that we just talked about elements within elements, so elements can contain other elements, or elements can contain attributes as we see here. So if we take a look, the element called component has child elements, which we've talked about, but notice it also has an attribute. The attribute is called name, and the value here is called facet manager. So that's an attribute. Okay, some rules for elements. We talked about what a start tag is and a close tag. So an opening element or an opening tag will have a less than symbol, the name of the element, and then a greater than symbol. If we have that, then we also have to have a closing tag, which is going to be a less than symbol. Then the slash on the American keyboard, that's the slash on the question mark key. The slash is, I always confuse backslash and forward slash, but you see the slash there, the direction that it's going. And I also learned that not all keyboards have that slash on the question mark. So if you're in a different country, it might be a different key, but nonetheless, you see it there. So we have the open element, or the open tag and the close tag. These together make up the element, in this case called tag. We know that we can have a singleton or a self-closing tag like so, where we simply put the slash at the end, and that means there is no open and close. This is essentially a self-closing tag. Now, order is important. We can't overlap as you see here. You can't have an open, and then a close for this open, followed by a close for the second open. That won't work. We could have over open tag, and then we could have lap open tag, then we could have lap close tag, then we could have the over close tag. So we can nest, but we can't mix together as you see here. Okay, so we talked about root element, and also, strictly speaking in XML, the white space that you see between tags, that also counts as an element. So if you're parsing, it gets a little funny, because how many children are there of, let's pick an easy one here, we'll say how many children are there of this option tag here? Looks like there's only one because you just see the array element, but actually there are three. There's the white space between the open option tag and the array tag, that's one. Then there's the array tag, that's two. Then there's the white space between the array and the close option tag, that's three. So strictly speaking in XML, white space counts as content. It can count as a child element of the parent element. Okay, so just be mindful of that. Okay, some rules around naming elements and attributes. We don't want to start names with numbers or punctuation marks. So numbers, hyphens, and periods are allowed after the first character, but we don't want to have spaces and some other special characters. A general rule, the name of an element should be descriptive. I typically just use alphabetic characters when naming an element. You could have a number in there or some other things, but just be safe. Stick with the standard, stick with the normal name. Don't start with a number. Don't use the equal sign because that's reserved. And don't use a space. That's a really easy one to forget, but an element name has to be all one word, no spaces. The colon character is reserved. We can't start with the letters XML because that is a reserved reserve content as well. And then when we're making an open and a close element, let's make sure that the case is the same. Generally, a good idea to make it all lowercase, unless you have a good reason to do otherwise. I typically try to make all of my elements and all of my tags lowercase. We can make comments within an XML file. We need less than, and then an exclamation, and then 2 dashes, and then we can enter our comment text, and then 2 dashes and a greater than symbol will close off that comment. So a couple general rules, and again, you can look at XML examples to kind of get the flow, get the idea of how it's going. Okay, simple and complex types. So if an element does not have any sub-elements aside from text, it's something we're going to consider simple. So in this example, title, SOA title, that's what we'll call a simple type. But notice book. Book is made up of title and author. And if we're being really specific, we also note the white space between open book and open title, the white space between closed title and author, and the white space between author, close author, and close book. So actually 5 children elements if we count white space. So this is a complex type because it is made of further elements, further children elements. So simple is title, complex is book because book contains title and author. Okay, white space, we talked about this. HTML does not care about white space, it ignores it. You can put as many spaces as you want in an HTML document, and it will only pay attention to the first one. XML does not strip white space automatically. When you're reading XML, you do have some options to say, hey, ignore white space, but by default, it does not ignore white space, so just be careful of that. Attributes. We talked a little bit about what an attribute is, so I'll breeze over this one a little more quickly. But we know that an attribute is in the open tag of an element, and we know it's going to typically have this name equals value combination, where the value is enclosed in quotation marks. Okay, now one question, when do we want to use elements and when do we want to use attributes? Because we can put data in each. A lot of this really depends on the author. Some people will use a lot of attributes, others will use not so many attributes. I like this third bullet point here. So attributes are used to represent metadata. So many times an attribute is used to describe an element itself. Talk about the element. Where elements, elements can have children. Elements can have child elements going on for several generations. Where an attribute is contained right there within the opening tag of an element. So really an attribute should just describe that element. Nonetheless, I see XML documents that have a lot of attributes, and I also see XML documents that just have a lot of elements and not many attributes. So you're likely to see a bit of a mix as you look through some XML. Okay, mapping relational tables to XML. In this case, you see that a book is owned by an author. So in other words, there could be multiple authors for a book. A lot of times college textbooks, you'll see that. So you could have a one-to-many relationship between book and author. So take a look at this XML document. We have the root element called library. It's the open and close element. Then inside of library, we have an element called book. So open book and close book. So what you see tabbed in one level here would likely be stored in a table called book, the title of the book, the publisher, and the year it was published. But then within that we see further indentations for author. And we see a syntax that we'll see a lot in XML, which is a plural followed by a repeating group of singular. So plural authors, and then singular author, singular author. We can repeat that singular author type as many times as we want within the plural authors element. So authors, in other words, authors plural indicates there will be multiple authors. This is how we would represent a one-to-many relationship because we have one book and it has many authors. What you see in the author tag here would likely go into an author table. What you see just indented one space from the book would likely go into the book table, and we would likely have a foreign key relationship between author and book when we actually look at this in the database. Now, you don't see the foreign key spelled out here in XML. It's implied by this relationship. The relationship that we have a book, and then a book was written by authors. So that's implied. But if we have a program that parses this XML and puts the XML into a database, it's likely that we would see a foreign key relationship made by that parsing program. In other words, I read the XML, I insert into database. As I'm inserting into database, I make sure that I propagate the foreign key from the book table to the author table. If you're not familiar with foreign keys, don't worry about that last part. But if you are, that gives us a little bit of context about how we can relate XML to a database table. Now, it does get a little trickier when we have a many-to-many table, for example, student and course. So one student can take multiple courses, and a course will likely have multiple students. So for this, what we'll have is our root element of enrollment. There again, you see the root element. It starts and it closes the document. Within that, we have student, okay? And we have a student ID, and we have a name. Within that student, we have a repeating group of courses. Now, we could have another student with that student with a unique ID, and that student with a name. And within this other student, we might see a repeating group of courses, and some of those may be duplicate with our student up above, Larry Page. So it's a little bit tricky because you notice that courses here is represented in two different students, but that is essentially putting together this enrollment concept here, where a student is enrolled in multiple courses and a course has multiple students enrolled in it. So you see we kind of have a many-to-many join concept here, this thing called enrollment. Okay, so we've seen several examples so far. Here's another example of a purchase order. Now this one, you might notice it's missing a root element, because the root element not only has to start the document, it has to end the document. But not to worry, that's simply an indication that we continue on to the next slide, where sure enough, we see the close element for purchase order. Okay, so in this case, we have a ship to. This is one concept, one element of the purchase order. We have a ship to names and address. We have a bill to name and address, which may be different than the ship to name and address. Some kind of comment. And then we have a repeating group of items. So we see this syntax one more time, where we have a plural, items. And then within that plural element, we have a repeating group of singular item elements. So items, plural, contains a repeating group of singular item elements. And each item might be something unique. In this case, we have a lawnmower and a baby monitor. Okay, parsing XML. So we have the XML. What do we do with it? Well, there are computer programs that can read the XML and can take some action based on the XML. So these things are called parsers because they will read the file. They'll verify that the file corresponds to whatever validation it should, DTD or XSD usually, then interpret the file and allow a programmer to access the elements within those files. There are two main concepts for parsing XML. One is DOM, or Document Object Model, and that's similar to what we see here, where we see essentially a tree or a hierarchy that's read into memory. So the entire tree is read into the computer's memory or the computer's RAM at one time. Many times we can use this because we want to look at the entire document and possibly put the entire document into some persistence mechanism like a database. Another common way to parse is called SAX. With SAX parsing, what we do is we simply read each element of the document and we fire an event each time we see an element. So module, component, facet, configuration, option, so on and so forth. Each of these are elements, and we're going to fire off an event each time we hit one of these elements. Now, as programmers, we will typically write what's called a handler. A handler is something that listens for these events and decides, is this an event I'm interested in, or is this an event I wish to discard? So, DOM reads everything into memory at once. SAX simply parses through the document and fires off events every time it sees an element or an attribute, and then we can decide if we want to handle that event or not. Okay, so we'll wrap up with some extensions of XML. XPath. XPath is a way that we can find out what is in an XML document by navigating through the elements. We'll take a look at each of these in future videos. XSLT will allow us to convert an XML document to another type of document, for example, some kind of presentation document. So we can take raw data and we can add some kind of formatting to it to style it up. And then XQuery is a SQL or structured query language type data query where we can search through an XML document. So these are some ways that we can use XML that we'll look at in some future videos. But in the next video, what I want to take a look at is how we can actually write XML, but we can write XML as HTML so that we can get some instant gratification and we can see the results of our work. I look forward to seeing you then. Thank you.